heavy casualties. It's well understood that gas would be of small value against ships in action due to the wind velocity caused by their movement and their evasive maneuvering. In addition, personnel inside the vessel's hulls are given excellent protection against gas by the air recirculation systems. On the other hand, a gas attack could be directed under favorable conditions against exposed personnel on a stationary ship. Such an attack might be feasible against the Japanese fleet if it avoids further decisive action at sea and is bottled up in a fortified harbor. In our test, then, the ship will be stationary, and the test will determine this. Can non-persistent gas be put down to cover an entire ship, including its tops, in sufficient concentrations to make instant casualties of the anti-aircraft gunners? If so, an air torpedo or dive bombing attack could be pressed home immediately after without the probability of serious losses to the attacking planes. In selecting material for the test, it is obvious that the impact fuse used on gas bombs against land targets would be unsatisfactory against a ship target. The cooling caused by the quick expansion of the concentrated gas leads it to mushroom and flatten out. Frequently, the heavy concentration of the cloud is not over 10 feet high. Thus, while it would be effective against land personnel in dugouts and foxholes, the low cloud would not ensure casualties among gunners stationed above a ship's main deck. Bombs with the same fuse dropped for water impact give an even less satisfactory result. In addition to the low cloud, most of the gas is removed from the air by the washing effect of the splash. An airburst fuse must be employed to create a cloud deep enough to cover all a ship's exposed personnel with lethal concentrations. Using the T-51 and the T-50E4 airburst fuses, the test begins. A series of 6 separate trials are flown by a single plane to establish the height of burst and to study the characteristics and travel of the gas clouds liberated. 8 bombs are dropped on each trial. First a raft, then a barge, both stationary, are the targets. The bombs are dropped singly and in 2- and 4-bomb trains. From these tests, it is established that the T-51 fuse is superior to the T-50E4, that the average height of burst is about 75 feet, that the gas cloud does not immediately drop and mushroom, but remains as high as the superstructure and tops of the ship for some minutes. We're now ready for the final test. The target is a ship's hulk with 2 barges moored to its stern, 700 feet overall. This gives a length of target equal to the Nagato class of Japanese battleship. From a tug, goats are loaded onto the target ship to represent Japanese personnel. 10 testing stations are established on the ship at locations where anti-aircraft weapons would be expected. The stations are placed at bow and stern, at different locations on the main deck, and at varying heights above it. Each station consists of a gas concentration sampling instrument, 1 unprotected goat, and 1 goat protected by a gas mask fitted with a Japanese Navy gas mask canister. Several unprotected goats have been placed on a guard boat, which takes its place 800 yards downwind of the target ship. CK non-persistent gas is used in the 1,000-pound bombs. 11 B-24 bombers make up our squadron, to which are attached 2 planes for observation and photographic purposes. The bombs are dropped from a height of 12,700 feet. 73 bombs are dropped by the 11 planes, each plane dropping in train at 50-foot intervals. The 11 fuses give ineffective high bursts, and the bomb release mechanism of one plane initially jams, causing a delayed and ineffective oversalvo. The gas cloud completely covers the target, horizontally and vertically. Its duration on the ship is 16 minutes in low variable winds not over 2 7/10 miles per hour. On the target ship, all unprotected goats, no matter where stationed, are killed. Also, all unprotected goats are killed on the guard boat stationed 800 yards downwind of the target ship. 30% of the masked goats are killed. The sampling instruments record that concentrations several times that which is considered lethal were set up throughout the target, thus indicating that this form of gas attack is feasible as a preparation attack to neutralize anti-aircraft fire immediately preceding an air torpedo or dive bombing attack. From this program of tests, the following conclusions are reached in regard to defense against chemical warfare. First, that protective ointment and 2 layers of impregnated clothing are bearable in the tropics and will not cause undue skin irritation. Second, with very little modification, the ointment can be made into a combination gas protective ointment, mosquito repellent, and camouflage face paint, without impairing the efficacy of any one of the components. Third, it is necessary to wear 2 layers of impregnated clothing to give adequate protection against the high vapor concentrations of mustard gas which result in the jungle. Fourth, this protection cannot be broken by any concentration of mustard gas vapor which it is practicable to set up in the field. Fifth, however, no amount of impregnated clothing tolerable in the tropics will give adequate protection against liquid mustard under 3 hours after a heavy bombardment. Sixth, the U.S. Army gas mask canister filled with ASC charcoal is superior to all other canisters tested and will give adequate protection against the heaviest concentrations of CK non-persistent gas which it is practicable to set up over any considerable area in the field. In regard to offensive use of chemical warfare, it is concluded, first, that all our standard gas munitions, both ground and air, are satisfactory for use on jungle-covered terrain. That CK as a non-persistent gas and mustard as a persistent gas are very effective under tropical conditions. Third, that the Japanese gas mask canister is inferior to all other canisters tested and will not give adequate protection against CK non-persistent gas. Fourth, it is concluded that non-persistent gas could be used successfully in a first surprise attack against the anti-aircraft personnel of an enemy fleet at anchor in preparation for an air torpedo or dive bombing attack. So, finally, the conclusion is reached that gas would be more effective against Japanese troops than against our own, and therefore, if gas warfare is initiated, it will be to our advantage.